So welcome everyone to this talk about SHACL-based data lifecycle management. And I would like to start with a short overview of the talk. So it will be about the linked data lifecycle. It will be about software components that work in this lifecycle phases. Data consistency requirements that these components have. Data validation standards that can ensure these requirements. We will show some validation use cases, and we will also give a live demo of our product. So with our newest product release, we support the whole linked data lifecycle. We have different lifecycle phases like ingestion, cleaning, authoring, linking, enrichment, provisioning, and analysis. And these lifecycle phases will work mostly RDF-based, and they have data coming in from the previous step and also data going out to the next step. Our product, PoolParty Semantic Suite, supports a lot of different functionalities and use cases based on semantic web, semantic AI, graph-based data management, NLP, machine learning, search applications, a lot of integrations. And we have several components in this semantic suite. So first, the graph editor is a general ontology-based editing tool where you can do filtered search and bulk operations on RDF data. The Thesaurus server, which is based on SKOS, enriched with ontology information for modeling, general data modeling based on the knowledge organization system. Unified Views is a data orchestration tool for processing large amounts of data in pipelines. PoolParty Extractor is a text extraction and corpus analysis tool. Semantic Classifier is a machine learning-based classification component. And finally, Graph Search is a faceted search and recommendation component. So all these components work on these different lifecycle phases. And yeah, as they work RDF-based, they have data coming in. They have to work on this data, doing processing and analysis, and they have some data as output. And for these components, we have some consistency requirements regarding the data that comes in. And we also want to ensure the consistency of the components themselves for the data that goes out.
So as Robert mentioned, we have some consistency requirements. So we just wanted to cover a little bit why we needed the data consistency. So obviously you need data to be consistent so that your data is of a certain quality and that it is what you expect it to be, so that the applications can process it correctly, and that the quality is as you want. And often, as I'm sure we all know, data can actually be quite dirty, quite complicated, particularly when you're bringing in data from different sources, and perhaps perhaps there's kind of conflicts in context, and things don't mean what you expect them to mean. So what we want to do is perform checks to ensure that it conforms to the scheme that we're setting out, and as much as possible so that it's accurate as well. And one good thing about using the knowledge graph is we can actually use the relationships between concepts to check some of the consistency and accuracy of the data. So not just checking that an entry has, for instance, a city and a country attached to it, but that the city and country also make sense in relation to each other.
Yeah, so next are data validation standards. To implement these consistency checks for conformance, we looked into several options how we can do this on the RDF data. So the first thing that probably comes to mind is SPARQL. So you can do it for querying specific structures in the RDF. We also would have the option to use a closed world version of OWL to be able to do the consistency checks, where apparently open world cannot be used for that. there are two main sort of standards for constraint validation, and that is SHACL and SHACL. So we decided for now to go with SHACL, and which is a language for validating RDF graphs against a set of conditions, for several reasons. So first of all, you can use RDF to define the conditions you want to check. It's easy to understand by humans, so it's easy to read it. It's quite good understandable. It can be processed by machines, of course. It has a well-defined semantics, so it's specified W3C recommendation. You can extend it via SPARQL if the language features are not enough for you. So you can do part of it with the basic SHACL part, and the things that are not covered, you can use a query to extend it. And yeah, as I said, it's a W3C recommendation, so it's an official standard. So how does it work? Yeah, basically you define shapes using RDF itself. The shapes define how the data should look like. And the SHACL processor, a piece of software, validates an existing data set against these shapes. We can use it to detect inconsistencies and also improve the quality. The result of this validation is a conformance report listing the violations where the data does not match the shapes. And this report is also defined in the recommendation. So you have a common basis on how to process these results, actually. That would be a difference to if you do it with SPARQL, then you get back some bindings, yeah, and wouldn't be really defined how to interpret it. But with SHACL, you get back this report. So here we have an example, which is actually about a SKOS concept in PoolParty Thesaurus. On the left side, we see the shape that we defined. On the right side, we have the explanations. So first of all, we define this as a SHACL shape. It is focused on nodes in the graph, not on properties. It targets instances of SKOS concept, so we can check everything that is an instance of SKOS concept in our data. And then we have some property requirements. First of all, the pref and the ort label must be disjoint, and for the pref labels, the language must be unique. And the third condition that we have here, we have for each concept in the thesaurus always a connection via broad and narrow to a concept scheme, which this check ensures. So it determines the path to the top using broad and narrow and top concept of and has top concept relations. And you see the minimum count is 1, so at least one path. And if that doesn't hold, you get back this message indicating a problem in the data. Okay, so now we come to the use cases.
Okay, so our first use case is just bringing in ontology into PoolParty Thesaurus server. So the constraints here are that it's a SKOS-based data model, and that brings some requirements with it as well. And then we can have additional component-specific constraints. So we'll just import RDF, and the data will be validated on import. So the import assistant will actually be running 17 checks in the background to make sure that the data is high enough quality. So if I just move to the demo.
Should I log in? Yeah, let's switch to the demo.
Oh yeah, I think you have to log in.
Yeah. So, oops. Okay.
Okay, great. So if I go to this project in PoolParty, and I'm just going to use the import tool to import the RDF. So here's one we've made earlier.
So basically, just select the file. We basically import one concept now into our thesaurus, and this concept has some problems. At least it doesn't look like we want it to.
Yeah. So now it's running the 17 checks. So obviously when you bring in data into the system, you want to check to make sure that it's following the SKOS standard, and also it's running extra checks to make sure it's consistent. So here we found 3 errors. I can move down. So we have these refer back to, if you remember what Robert was just saying when he was going through the actual syntax, there were things like you can't have multiple preferred labels, so you can only have one preferred label in each language. And here we've got this report which says we have 2 here. So we have, in English we have Munich and München. München?
Yeah.
And you can see here in the tool we could actually choose to repair it as well, which is useful. So it's a way of kind of a way of managing your data as well as checking it. So another of the things that it was checking in that syntax that Robert went over was that you can't have the same literal, which is both the preferred label and an alternate label. You have one preferred label, and then you can have as many synonyms as you like. And here again we have the same word, which is both the alt label and preferred label. So again we could choose to sort of repair it here. Right, and then there was a third issue as well, which I won't go over. Sorry, was it F11?
Mm-hmm.
Cool.
The upper one.
Yeah. Okay.
Okay. Mm-hmm.
Yeah, this is you.
This is me.
Yeah.
Yeah. So in this case, what we saw, it would not even disrupt the functionality of the thesaurus manager, but apparently the quality would be not as we would like it to be. Actually, based on the SKOS standard, with this label requirements. But if we do not have this connection to the concept scheme, it would not show up in the thesaurus tree, in the visual representation, and you would not be able to edit it, use it. The next example is about the PoolParty graph editor, which is not based on SKOS, so it's based on ontologies. It actually generates the UI based on ontologies. It's a filtered search where you can select the filters based on the ontology elements, the classes and properties, and you can define some conditions. And the result is, in this case, not a tree, but a tabular view on the data. So let's take a look on that. So, yeah, we have here several graph editors defined already. So they work on the same data, on the same stores and graphs that the thesaurus manager does, but they create a different view. So here you can see we have some saved filters that show some resources of our next use case actually. You can define these filters on top, doing a class-based filter with a Boolean query option. The same for the properties where you have several conditions. You can search for the property has to be there with specific values, must not be there, or another option to just show it in the table result regardless if it's there or not. So, and here, of course, this is a much more flexible way of handling the data, so you're not restricted to SKOS. There are less requirements for the application itself, but apparently because you can do a lot more flexible data management here, it would be beneficial to actually formulate the checks based on the use case. So in this prototype, we built in a SHACL-based validation, where you can paste in your SHACL shapes and run it against this graph editor-based data stores. So the next use case is actually from one of our clients. It's about the legal data, and in this case, we have legal entities, which are basically companies. They have board members related via has board membership property, and these board members have a status that is defined using the has board member status property. And the constraint that we have here is there must not be more than 2 active board members for each legal entity. So how can we check that? Let's go back here. Here you can see a filtered list of these companies. They have some board members, so board member 1, board member 2. This one has 1, 2, and 4, and the last one has 1, 2, and 3. And if we look at the board members, we see that 1, 2, and 3 are active, and the board member 4 is not. So if we go back, so we expect the company 3 to cause a violation because it has 3 active board members, whereas the company 2, it has 3 board members, but one of them is not active, and the company 1 only has 2 board members. So if we go to the validation, so I have some predefined shapes here. This is for checking these board members. It's the basis is a SHACL shape that is targeting the legal entities and checking for the has board membership property. And we use part of SHACL, a Sparkle extension to ensure that this is these are not more than 2. So we run the validation. It's a little bit too. And we get back one constraint violation, which is exactly this one company that we saw before. This is only a prototype showing just the URI. So in the upcoming version, of course, you will get a better view of this report.
Okay, so the next use case, you can see it's visually modeled in this shape. So basically it says a legal entity is located in a city and a country, and the city has to have a narrow relationship to the country, so the city has to be in the country. Okay, so a graph, legal use case. Right, so again, I'll run another predefined SHACL query over it, and it will be consistent geo information. So if I press validate, and here again we have an error. Sorry, scroll.
This locations.
What about the locations?
So, yeah. Go and search and edit. Search and edit.
Oh, search and edit. I was going to show it in
the
thesaurus.
Yeah, just to show this countries and cities, here we can see that you have some sort of inconsistency because Paris is not located in Austria, and that's exactly what the shape is checking. So it doesn't trigger for having only a city, so you must have both.
Yeah.
And they have to be connected. so we can ensure that.
So if you look in this thesaurus, we can see, I mean, as is common sense, obviously, that the city has a narrower than relationship to the country. So Paris is in France and Vienna is in Austria. So we can look at the organizations, and I happen to know where the error is. It's like magic. So here we see the error that we have a company which has city Paris and a country Austria, and obviously those don't make sense.
Yeah, so the next use case is for unified views, our data orchestration tool, where we can process streams of data and pipelines. This is basically about processing articles that are annotated, scientific articles, where we process large amounts of these documents. And it's a publications use case. There we have similar requirements. I can show it on the slide. We have these publications that might be linked to journals. And we want to ensure that if a publication is linked to a journal, it must have an impact factor. So it would be about data quality here. That we ensure that this impact factor is always there. I will not show the data orchestration tool here, but show it again with the graph editor. So publications, you will see a list of these journals, and they have this impact factor, but there are really a lot of it in the store, and for the validation, we have the where is it? Publications check, which again is using target class targeting instances of publication, and based on this journal property, we want to check that the impact factor is always there. So we can run it, validate it, and again get back a violation where this is not really in the data as it should be. So yeah, okay. So that's all for this talk. I hope you enjoyed it. Thank you very much.
Any questions?
Questions? Why are you dropping into SPARQL on those constraints rather than just using native SHACL?
Yeah, because previously there hasn't been any standard for doing these checks. So SPARQL is something that is very generally useful.
No, sorry. In the validation there, you obviously.
Why okay, yeah, there are some things that you cannot express with SHACL itself. For example, this geoconsistency use case, where I have this triangle. This is not possible to express it with the SHACL core, because you cannot, how should I say, you cannot use the focus node twice in the definition of this.
It's an expressivity issue rather than
yes. Yeah, the implementation is not complete yet, so we are missing some language features. So right. That's correct. But there are also some cases where it's not sufficient to use the core SHACL. So you can always extend it, but you still get back this standard-based report. Even if you do everything with the SPARQL part, you always get back the standard-based RDF-based report.
Is that your own SHACL validation?
No, we use the RDF unit implementation. Yeah.
And is there a plan to make a UI,
yes,
friendly
it is.
wizard or something to
Yes,
help
yes.
that non-technical?
Yes, of course. So this is just a prototype for demo. Of course, it's not so easy to write these shapes, and it would be nice to have a UI to define them. And maybe also do some, what is also a problem is, you know, if you have these target classes, and you probably mix up your URIs for the classes, or you have some problem that you won't get any errors reported. That can also happen, so we would like to give additional features, yeah, if there is something that the shapes can actually hit and things like that, yeah, so that it's more convenient.
On the slide 18, there is a
18?
18.
Yeah.
There's a necessary and sufficient condition here. Can you
Yeah.
elaborate a little bit about it? Does it mean that like you are doing inference with this? Or
Sorry?
I'm saying journal, imply, factor.
No, that was it's actually to state it as a logical condition here. So it's not directly related to SHACL itself. So. So in this case, it would be a necessary condition for the.
Yeah, because that was more my question. Because if you compare SHACL with OWL, that's one of the big differences.
Yeah. You're absolutely right. There's a lot that you can express with OWL actually. For example, these cardinality constraints. But the problem is the open world based processing, which would infer you some classes based on the cardinality and not vice versa. So for constraint checking, you would need some closed world approach.
Yeah, my question was exactly about this. So overall, what do you think are the advantages of SHACL over OWL? This open world, closed world.
Yeah, so you can express actually more regarding these constraint checks. For example, if you have these things that are linked over several relations, that would be actually not possible to express that with R. And yeah, it's standard based, so that's really important for us to base our implementations on W3C recommendations to have a common basis for integration and also running applications on top of it.
But OWL is standard based as well.
Yeah, sure, but not the closed word interpretation.
Right.
So there are some approaches to that, but they never came up with a standard on that. Yeah.
Do you have any experience using SHACL rules for data enrichment?
For data enrichment?
Yeah. So, for example, you find that certain elements are missing in your shape, and you want to go to some external system and actually bring that data in.
Yeah.
In theory, you can use SHACL for that. So, do you have any experience doing it?
Yes. We're building these pipelines for unified views, where you can have several pipeline steps. So one could check if there's something missing, and trigger an enrichment then for the next one. So we offer an API for that. You can actually code it yourself if you like. It's basically an interface that you have to implement to create this pipeline. So you could also use it for enrichment. Yeah.
Can I do another question? Another question about UI and some user-friendly way to view what are the rules. Have you looked into maybe an alternative syntax, potentially something similar to what people are doing with reification? So if you've seen reification syntax.
Actually, the idea would be to have something similar to what we have here in this filtered search, that you can just define the conditions that you want to have based on the. Of course, these conditions come from the ontology. You have classes and properties, but we could also use some SHACL properties to define these shapes, so that you have a building system for coming up, and it automatically generates the shapes. In this case, it's a SKOS-based search based on the ontology. We also support here that you can actually show the query that is generated in the background and reuse it if you like. So the same we would like to do for SHACL validation. Thank you very much.
Thank you.
Thank you very much.